Hello students and welcome to my math class. Today our chapter is factors and multiples. So let's start. Looking back, in grade 4 you learned about factors and multiples. Let's revise them first. We all know that factors are the numbers that are multiplied to give a product. For example, factors of 10 are 1, 2, 5 and 10. Because 1 into 10 is equal to 10 and 2 into 5 is equal to 10. Therefore, we can say factors of a number also divide that number without leaving a remainder. Now, what this means? Let's say you're given a number 10 and you want to check if the number 2 is a factor of 10 or not. How do you do it? So, divide the number 10 by 2. 2 5s is equal to 10. So, giving a remainder 0, or it seems like saying it's giving you no remainder at all. It's without leaving a remainder. Yes? Yeah. Now I can proudly and confidently say that number 2 and number 5 are what are they? Factors of 10. So thus, the factors of a number also divide the number without leaving a remainder. With this, we have learned what are factors and how to see if a given number is a factor of another number or not. Let's see one more example of 12. 12 divided by 1 is equal to 12. 12 divided by 2 is equal to 6. And finally, 12 divided by 3 is equal to 4. So here we have factors of 12 are 1, 2, 3, 4, 6 and 12. With this we have learned what are factors. So very simple, yes? Now let's see what are common factors. Now for this I'm going to take two numbers, 10 and 12, and I'm going to see the common factors between them. Okay. Let's draw a Venn diagram. If you don't know what is a Venn diagram, it is spelled as V-E-N-N. So basically when you have a two circle like this, intersecting each other to have a common area like this area in the center, this shows a Venn diagram. Now Venn diagram is used to compare and also see similarities between anything, okay? And for this our case, we want to find out the common factor of 10 and 12. So in this given area, this center part is going to show us the common factor of both of them. Now let's see how it works. Okay, so first you have the numbers. As you can see, the first circle is the factors of 10. These are 1, 2, 5 and 10. The center part shows the common factors, that is 1 and 2, very simple. And the second circle shows the factors of 12. These are 1, 2, 3, 4, 6 and 12. Yes? So with this you have learned what are the common factors. These are very simple. They are just 1 and 2. So far we have covered what are factors and what are common factors. Yes. Now let's see what are multiples. Very simple. Multiples are the products that you get when you multiply a number by 1, 2, 3, 4 and so on. Okay. Let's imagine a scale from 0 until 12. It could be more of course, but let's limit our numbers till 12 for now. Okay. Now from this scale, tell me what are the multiples of 2? You know it. It's going to be 2, 4, 6, 8, 10, 12. Very simple. I have got 2 by writing 2 into 1 is equal to 2. I have got 4 by writing 2 into 2 is equal to 4 and so on. Yes? So this orange curve shows the same thing. From the given scale, I have shown here the multiples of 2. Yes. Let's say multiples of 3. It's going to be 3, 6, 9, 12. So in this given scale, I have the orange and the blue curve showing the multiples of 2 and 3 respectively. So if we're talking about multiples of 4, for example, it's going to be 4, 8. Now how is it? Because 4 ones are 4 and 4 twos are 8 and 4 is 12 and it goes on. So we have understood what are multiples. The basically the product which you get when you multiply a number by 1, 2, 3 and so on. Okay, that was easy. Now I want to learn what are common multiples then. Now for the common multiples of 2 and 3, if we see in this carefully, we have here 6 is common in both of them. Yes. And even 12 is common. It could be more common numbers because we're limiting until 12 for now. Let's focus on that, okay? So two numbers are common and thus I can say now the two numbers 6 and 12 are the common multiples of 2 and 3. Very simple. So in this whole page, we have learned and revised what are factors, what are common factors, what are multiples, and what are common multiples. It's a revision of grade 4 before we start with grade 5 portion, okay? Is clear for you? Let's move on. First topic for today is rules of divisibility. What do you mean by this? The rules of divisibility will help you find which numbers divide others without leaving any remainder. What this means? We saw an example of number 10 where 2 and 5 are with the factors of 10. Can I also say that the number 10 is divisible by 2 and divisible by 5? Yes, I can say, because I'm dividing the number 10 by 2 or 5, I'm getting remainder as 0. This is what it means, okay? Let's first the divisibility of 2, 5 and 10. The rule simply says, this rule is very important to keep in mind, because from this given area, from this given portion, if you know the rule, how it works, you'll be able to see any number in random and tell me and tell everybody of your class which number is divisible by 2, 5 and 10. The rules say here, a number is divisible by 2 if the last digit is 0, 2, 4, 6, 8. Let's take an example for now. Let's take a number 16 for example. You know, because you have learned the table of 2, because it gives you 8 and this gives you no remainder or 0 remainder. Yes? Yeah. But as you can see in this given number, we have 6 as the last digit. That is following this rule. Okay? So which means it is by 2. Let's take another number for example. Let's say 18 for example. Again in 18 I have 8 at the end. So it is divisible by 2. Yes? Because we know that 2 9s are 18. Simple. Now, if we take a huge number, a very huge number, it's a 3, 6, 9, 8, 7, 4, yeah. Now, this number is quite huge. But looking at this, can you tell its number divisible by 2 or not? Yes, I can tell you, because at the last digit, here I have 4, which means this number is divisible by 2. Yes, simple. Similarly, for 5, it should have 0 and 5 at the end of the last digit as such. For 10, it should be 0. Very simple rule. Let's see one more example of this and how to apply them. Okay, let's have a look at this. So we're given two numbers 24 and 14. We have to apply this given rule and tell us is it divisible by 2, 5 or 10. For number 24, as you can see, the last digit is 4, meaning this number is divisible by 2. Tick mark. By 5, no, because I can't see no 5 or no zeros, is no. For 10, also no. For number 14, I can say it is 0. And as you can see, 0 is present in all of those options. Yes? So it is yes. Tick, tick, tick. So simply means that the number 40 is divisible by 2, 5 and 10 all. And number 24 only by 2 and not by 5 and 10. Simple, yes? Again, to revise for all of you, divisible simply means that when dividing the given number, let's say number 40, dividing it by 2, it should give remainder as 0. That is what it means, yeah? If you see this question, for example, carefully, let's how it goes, long division method. We have 40 and 2. You know that 2 is 4, yeah? Correct. Now you get 0 and then you add a 0 over here to give you 20. Yes? Divisibility of 3 and 9. The rule same, a number is divisible by 3 if the sum of the digits is divisible by 3. Now what this means? This simply means that if let's say I have a digit with me, let's say number 81 for example, and I want to check if the 81 is divisible by 3 or not, okay? Then when I divide by 3, I should get remainder as 0. Is it 2 or not? How do I know it? They're saying to find out the sum of the digits, okay? This means I should have done 81 as 8 plus 1, which gives me 9. Now you know easily 9 is divisible by 3 because we know that 9 divided by 3 gives us 3. That is, remainder is 0 in this case, meaning 9 is divisible by 3, which means that even the number 81 is divisible by 3. Simple? Yes. Similarly here they have told about number 9, where they're saying that a number is divisible by 9 if the sum of the digits is divisible by 9. 3, 6, 9. And this number is quite huge, isn't it? Now how do I know if this number is divisible by 9 or not? Very simple. Write down the sum of this is going to be 3 plus 6 plus 9. I'm going to get what? 3 plus 6 is 9 plus 9 is 18. And as per 9 2s are 18, so giving me 18 over here, which simply means that 18 is divisible by 9. So similarly, even this number is divisible by 9, okay? Let's see a proof for it. We have 369 divided by 9. As per 9 4s are 36. We have 0 here, we get 9 down, and 9 1s are 9. So give me 0, and it is true, okay? Let's see two more questions or two more numbers for this given problem. Here we have two numbers 81 and 84. They have given the number as well and also the sum of digits. You have to find out is it divisible by 3 and 9. Okay, first number is 81. We have already done that, isn't it so? It was divisible by 3. We have seen that. Is it by 9? Yes, it is, because as per you know, the number 9 itself is divisible by 9 itself. We're going to give you answer 1 and remainder would be 0. Yes. Now, which means that the number 81 is divisible by both 3 and 9. Yes, correct. Okay. The number 84 we have next. Number 84 becomes 8 plus 4, that is 12. The 12 is divisible by 3, of course, so giving me number 84 divisible by 3, but 12 is not divisible by 9. How do you know that? Because when I divide 12 by 9, for example, I'm getting 9 ones and 9, giving me 3. So I have a remainder as 3 and not as 0. This shows that the number 12 is not divisible by 9, and that is cross. Yes? If this is wrong, meaning even the number 84 is not divisible by 9. Very simple. So the number 84 is divisible by 3 but not by 9. Yeah? Clear? Yes, move on. So here in this whole page we have learned the rules divisibility for 2, 5, 10, 3 and 9. I hope is clear for you. So keep in mind for 2, 5 and 10, this thing, the last digit is important. Keep in mind what it should be. Learn that well. And for 3 and 9, keep this condition in mind. It's very simple, my friends. It's very easy to keep in mind and learn them. Now let's move on.